Good afternoon. In this video, we're going to start programming our cell, and we're going to do this in multiple videos just because it's a little bit longer and we want to break up the videos just a little bit. But basically, we're going to start out with programming the initial pickup area. So let's look at some of the programs that we have created already. Let's first look into the data registers that we are going to have set up. So the first data register is going to be a counter just in case we have it. And then we have our start row and column. So this is meant for counting which part are we going to be on per row and per column. We also need one for the end. So we did column end and row end. So this is going to be our placement. Then let's go into our position registers. Inside our position registers, we have a couple saved points. The first one is this home position, which the robot is at right now. We have a pickup position, which is the first initial part. And then we have the lathe chuck position. And then we have the placement position. Now both the pickup and place positions are going to be changing as we manipulate that position register. Going down, we have our offsets. So this is the number in which we're going to offset from left and right to do the rows and columns. So we have our offsets for the in feed, and then we have the offsets for the out feed. We also have a couple tool offsets because we're going to come down at a safe position and then back up to that safe position. We're going to utilize our tool offset. And then because we're in a little bit more confined space when it comes to the lathe, we made a lathe tool offset as well. Now the numbers that we put into this, we initialized it as zeros. We don't have to worry about this actual number because we're going to initialize it in our actual program, but just to show that it was at zeros, and we have it set at right now 300, but that may change depending on how the program actually plays out. So those are going to be the main position registers and data registers we're going to utilize. We're going to be using tool frame number 1, which is our gripper, which we modified to be a little bit smaller so we can fit inside the lathe a little bit easier. And then we also have our frame 0, which is going to be our world mode, which everything's going to be based off our 000 for our robot. Going on up here, if I go to my blank pickup, so here's my pickup program. Again, these are simulation programs to represent that we are picking something up and then we're also placing it. In actual programming, you would have either a robot output or a digital output and picking up your device. So robot output may be hooked up to your solenoid or some sort of electronic device. So those are going to be your actual outputs. So that's where the programming and the programming in real life differs a little bit. So if we go to the blank pickup, this is where we have the jaw close, and then we have the finish part drop off, which is over here. So these two are going to be the pickup and the drop off. Then we have the programming for our actual jaw open and jaw close. So if I close this out and then I go to our program, so here is our jaw close, which is going to be a digital 1 output of off, and then it's waiting until that happens. And then we have jaw open, which means digital 1 is on, and we're waiting for digital 1 input to be on as well. So jaw open and close was a program that we did. We can actually delete this one so we don't get confused. Then we have the lathe chuck close and lathe chuck open. So these are just opposites from each other. We have the chuck drop off. So this is the program in which we drop off the actual part into the chuck. So you can see the lathe chuck opens, it waits a second for that to happen, and then it drops the part off, calls the lathe chuck to close, and then we close it. Then same thing for lathe chuck open. So when we grab it, then the chuck opens and then we move it out of the position. We have the lathe door open and close. So basically these are opposites. And then we also have the turret out of the way and also in the safe position. So ready to rock is forward, and then safe position is back. So those are going to be the main simulation programs in which we're going to call upon as we program our robot. Alright, so the first program we're going to create is getting the simulation to be in its start point. So we're going to have our robot in home position, we're going to have our door closed, we're going to have this closed, we're going to have our turret towards the front. So everything initialized so that when we begin our program, everything is at the same start point. So let's go select, and we're going to go create. And this time what I'm going to do is I'm going to put 1 in the beginning, underscore, and then we're going to simulation item start point. So the first thing we're going to do is we're going to make sure that our robot's at home. So let's go add move point, and we're going to do a joint movement, and we're going to use position register number 1, which is our home position. Now later on we'll actually program a smarter way of doing home position, because right now, depending on where the robot is, if we call home position, it could crash into our devices or our lathe, and it could cost thousands of dollars to fix. We always want to make a smarter home position. So you saw in all these videos so far, I just called out a home position, assuming that the robot's not going to run into anything. Later on, we'll make a very smart home position in which it looks at where the robot is in relationship to the tables, the machines, and the fixtures around it. So it can make a determination based on where it's at to make the best course back to home position without crashing into things. But right now we're going to just call it as a home position because this is a simulation, and we will do this a little bit later. Let's add the turret in the correct position. So let's go add new instruction, call program, and the first thing we're going to do is lathe turret in rock and roll position. So there's our rock and roll position. Then let's go down to end. Let's go new instruction, call. Next one is going to be the lathe chuck, actual chuck parts, going to be inwards, we'll call it. So lathe chuck closed, because we're going to open it. And then we're also going to call the door closed. So now that we have the lathe turret at rock and roll, we have the door closed, and we also have the chuck closed as well. So this is going to be our simulation starting point. So if we run this, everything is going to be closed, chuck's going to be open, and then our turret is going to be also towards the front. Let's also make sure that our jaws are open. New instruction, call program, and then here's jaws, and we're going to have them open. So now that everything is set up for our first simulation program, let's make a new program called the master program. So we're going to go select, and we're going to create, and once again I'm going to go A, so everything's in the beginning part. So A, and we're going to call this master lathe program. Enter, and we're going to enter into this. And the first thing we're going to do is set up our frames. So we're going to new instruction, miscellaneous, remark. Let's add frames to the beginning. And then new instruction, and let's set up our frames. So utool number 1, and then our user frame 0, which is going to be our home 000 based on the robot. Then let's go to edit command, ECDM, and insert a bunch of lines. So let's insert maybe like 30 so we have some space. Okay, so the first thing we're going to have is we're going to reinitialize our simulations. So we're going to go new instruction, miscellaneous, remark, and we are going to put in our heading of simulation item start point. So simulation items at start point. And then we're going to call upon that program. So new instruction, call program, and then we're going to have a simulation start point. So we reinitialize our utool, our U-frame, we call upon that simulation start point, and then the next thing we're going to do is we're going to set up all our variables in which we're going to initialize everything to be at 0. So I'm going to just call this as variables. So inside the variables, let's create a new program for initializing all the variables. Now we can initialize here, but I'm going to keep this program pretty streamlined. So I'm going to go select, create, and this is going to be a non-motion program, so we're going to modify that. But first let's call this something. So A, and then let's go into the actual program in which we're going to start initializing our variables. So the first thing I'm going to do is I'm going to initialize that counter just in case I need it. So I'm going to equal register number 1, which is our counter, and we're going to initialize it as 0. So the next thing we need to do is we need to do the other counters. So if we go back under data here, and type registers. We need register 3, 4, 6, 7. Register number 3, and we're going to set that to equal to 0. And then we need register number 4, and we're going to set that equal to 0 as well. So now that we have our registers all set up, let's now set up our position registers. So I want to add in a few lines here, and let's go our position registers now. So the first thing we're going to set up, so let's go to data again, type position registers, and we're going to set up number 10, 11, 14, and 15. So 10 and 11 are going to have two different parts to it. We need both X and Y. And then the 14 and 15 are just a single item, which is the Z-axis. Let's go edit. Let's go registers equal to position register IJ, and we're going to use position register number 10, which is our offsets in feed, and we're going to first initialize the X coordinate, which is number 1, and we're going to set that equal to 0. Then we're going to initialize our position register IJ, number 10, and then the Y component, which is number 2, and we're setting that equal to 0. Then let's go the registers equal to position register number 11, and then we're going to go the X component is equal to 0, and then we're going to go position register 11, and Y component is equal to 0 as well. Then let's do our tools. So new instruction, registers equal to position register number 14, which is our tool offset, and we're setting the Z component, which is 3, and let's set that to, say, 300. So that's our Z component. Now we don't know if this is going to be positive or negative yet. It all depends on our tool frame. So we'll have to go in there and check it. So new instruction, registers equal to position register IJ 15, and we're setting the Z component, and we're going to make this one 100. Or 125. I think we have that set as 125. Let's go in there and actually look at it. We did a little bit of calculations to see what it looked like. So let's go position and 175. So let's make this 175. There we go. So now we have all our variables started. We may add a couple variables as we go through the programming, but this is where we're going to keep them. So let's give some headings to this. So we have the data, we have the offsets, and then the tool offsets. All right, let's go back into our main program, master lathe. And then here's where we're going to add our variables. So let's call upon that program. So now that we have our variables, let's create our program for our lathe pickup. So let's go to the next row here. And then we're going to go part pickup. So let's create another program for part pickup. So let's go create. And this is going to be a motion program, so we're not going to change that first motion group. And let's go enter, enter. And the first thing we're going to do is set up to make sure our frames are correct. So we got our frames. Let's go just like 10 lines or so. Alright, so now that we're in home position, let's just make sure we're at home position. Again, we will make a smarter home position later on. We got our home position, and now we need to go to our starting point. So let's actually go to our program. So this is going to be our actual pickup program. So let's add a couple move points. So let's go add move point. And from our home position, we're going to go as a joint movement. Now before we change this, let's just go edit our default motion and make sure that they're what we want it. So I have it set as 1000, 1000, continuous motion of 20. I usually go between 20 and 30, and then we have 100%, 20 point. So if you want to modify that before we start programming, just go into the edit add point and then edit our default and there. So I usually call it edit definition, but it's just editing our default. So we're going to go as a joint movement, and then we're going to go linear down to our position. So we're going to linear down to that position, and then we skip one line, and then we're going to pick up, and then we're going to linear back up again. So we're going to add move point, linear back up. So right now you'll see this as position 1, position 2, position 3. We're going to use a position register for our point. So position register number 2 is going to be our start point. So let's go in here, let's go choice, position register number 2, which is our pickup position, choice, position register number 2, choice, position register number 2. So now what we can do is just go step mode and then shift forward, and it'll bring us to that position. So all 3 of these now have the asterisks because we are at that position. Now we need to do is add our tool offset to this. So go arrow all the way to the end and then go tool offset, position register, and we're going to use position register number 14, which is our tool offset. Then it's going to go down to this position, pick up our part, and then linear back up to our safe position. So let's add our tool offset, position register 14. So let's try this out. Let's run this. There we go. So now we have our position register. Now we need to add our pickup area. So let's go to line 10, the one that we skipped, and let's go new instruction, call program, and then we are going to do our pickup. So the blank pickup, and that'll allow us to pick up that part. So if we run this now, picks it up. And then if we want, we can go back to our home position afterwards, because it makes probably sense to swing from our home position over. So let's go to number 12 here, all the way down, and then let's add our home position to the end here. We'll just clean this up just a little bit. So now what I'm going to do is just going to add some headings here so that it just has a little bit more clean to it so we know exactly what's going on. So I'm going to pause the video and then come back and just kind of show you what it looks like. Alright, so I just went back in here and I just cleaned it up a bit. So we have our pickup program. So here's our safe position. Here's our pickup position. Here's our pickup simulation. Then we go back up to our safe position, and then we go to our home position. So let's run this and see what it looks like. Goes to our safe position, and now we have our beginning part set up. Inside the main program, that's where we'll actually do the loops, but this is basically the same thing. It's just using the offsets that we're going to utilize. So let's go in here also and let's add our offsets to our program so that we're able to offset left and right as we create it. So we're going to go to the end of our safe position, and we're going to go offset frames, position register, and we're going to use position register number. Let's go to data. Here's our offsets in feed. So we're using position register number 10. So let's go back in there, position register number 10. So let's do that for each one of these. So just double check to make sure we have position register on each one of these motion groups. So we have position register number 2, pickup position, and we have a tool offset of upwards, and we also have an offset of the infeed. So that will allow us to shift over each time we do that for loop. Then we have the pickup position, so let's insert a line here just to make it a little bit neater. And then we have our position register, no tool offset for that. Then we have our pickup. Then we have our safe position that has the tool offset along with the offset position register. Let's add a line here as well. So now this program is all set up. Home position doesn't get any offsets. So this is all set up so that we can now pick up our part and use a for loop to shift over every single time. Let's add that to our main program. So let's go select, and let's go to master lathe program, and then here's our part pickup. So let's go add new instruction, call program, and then we have our lathe pickup. So now when we run this, the whole thing runs to where it's supposed to be, and we have our variables. Alright, so when I was running this simulation, I kept on getting a interpolation 214 error, and basically doing some research that has to do with motion groups. So if I go into the actual motion group for my master lathe, I noticed that we had it as an asterisk. So let's go detail, and right now we have an asterisk here. Let's go to motion group number 1, enter, and then let's go back to that program. So let's go to the end, master program, and now when I run this, I should not get an error anymore. So now everything is running properly. So picking up, and now we're at that position. So now we have our frames, our simulations, our variables, our pickup. The next video, move on to the placement table, and then we'll also work with our lathe part, and then we will do the for loops after that.